Hello everyone, thank you for signing in and watching my live stream. I'm Mr. Matt and this is Dr. Tot. Would you like a cookie, Dr. Tot? Yes, very good. And welcome to Pre-Algebra. This week we're going to be talking about division of whole numbers. And I want to start off by apologizing. We had some internet problems, so I wasn't able to stream on Monday or Tuesday. So I'm here now with session stream 1, and I'm going to be recording, doing another stream to make up that's outside our regular time of Monday, Wednesdays and Fridays from 5 to 5:45. Those are our regular stream hours. In between now, today, and Friday, I'll do another stream for session 2. So then we're back on track on Friday for session 3. So just my apologies, everyone, and thank you very much for your understanding. Sometimes the internet isn't fast enough with everybody using it all the time, especially at these hours. So I do appreciate your understanding. Now, talking about division. So last week we were talking about multiplication. Multiplication is the scalar projection of one value over another value. So 3 times 4 is 3 4 times, or 3 plus itself 4 times, 3 plus 3 plus 3 plus 3, which is 12. Conversely, you can think about it as 4 plus itself 3 times. 4 plus 4 plus 4 is also 12. You can do the flipping around because remember that addition and multiplication are commutative. Subtraction and division are not commutative. You cannot switch the order around and get the same result. 3 minus 4 is negative 1. 4 minus 3 is positive 1. Those are two different values, whereas compared to addition, 3 plus 4 is 7. 7 plus 3 is also 7. 3 plus 4 is 7. 4 plus 3 is also 7. So you see that you get the same result no matter the order. The same thing is true for multiplication. The order doesn't matter because multiplication is commutative. 3 times 4 is 12. 4 times 3 is also 12. But division, just like subtraction, is not commutative. The order does matter. 4 divided by 3 is 3/4, and we're going to get into fractions in another lesson. But just trust me for now. 3 divided by 4 is 3/4. 4 divided by 3 is 4/3. Those are two totally different numbers, two totally different fractions. And so we don't get the same result with subtraction or division when we change the order. So we have to be careful about that. But in general, and we're going to get into this written out when I share my screen with you, but I just want to generally overview that division represents the separation of units into equal groups. So let's go ahead and take a look at that. Whereas multiplication, like we said before, was the scalar projection forward, division represents the scalar projection backward. And just a reminder, these are live streams, so there is a little bit of a delay with the iPad, but I'll keep track of that. If there's any questions at any point, please let me know. You can respond in the live chat function, or if you're watching the recording, you can drop a comment below and I'll get back to you ASAP. So I just want to read out the overarching theme here, and then I'm going to scroll back up to explain some things visually. So division is the separation of a value into a certain number of equally sized groups. Where multiplication was the scalar projection forward of one value by another value, division is the scalar projection backward of one value by another value. Okay, so it's reducing by, so you can think about it as reducing it by a certain portion of the original value. Not relative to 0 necessarily, relative to the original starting value that you have. If you're taking 10 and you're reducing it by itself by 1/2, that's different than taking 100 and reducing it by 1/2, because 100 is a larger value than 10. So the portions that you take of each value necessarily are going to be different. We can think about division also visually So what we said before, division is the separation of groups into a separation of a value, of a number of values, number of items I should say, into equally sized groups. So for example, if we have, let's say that we have 6 items here. So we have 6 tennis balls, 6 apples, whatever you want to think about it as. So if we have 6 items, and we wanted to divide these 6 items into 2 equally sized groups, then you might do something like this. And there has to be the same amount in each group, so we could split 3 of these values to the left and 3 of these values to the right. So in the 2 groups, they're equally sized. There are 3 items in each of the 2 groups. So 6 divided by 2 is equal to 3, because 6 divided into 2 equal groups means that there are 3 items in each group. However, if we were to take 6 items and divide them into 3 equal groups, then you might do something like this, where we split the 6 values into 3 different groups, and then each of them would contain 2 values themselves. So if that's the case, that means that 6 divided into 3 equal groups is 2 units, because there would be 2 values or 2 items in each of the groups. So 6 divided by 2 is 3, but 6 divided by 3 is 2. The same thing could be true if we took 6 items and just divided it into 1 group. Then it's not really changing at all. We have 6 divided into 1 group means that that 1 group would contain those 6 items. So 6 divided by 1 is equal to 6. Similarly, I want to talk about 2 situations involving 0. I apologize, there is a little bit of more of a delay than I expected. If you give me 1 second, you might see my screen go away. I'm just going to reset the connection really quickly. My apologies, I just want to, usually this will speed it up a little bit, because that's really slow. Okay, sorry about that. So, as we can see, if we take 6 items divided into 2 groups, then each of those 2 groups would have 3 items in them. So 6 divided by 2 is 3. If we take 6 items and divide them into 3 equal groups, then each of those equal groups will have 2 items in them. So 6 divided by 3 is 2. If we took those 6 items and divided them into 1 group, then that wouldn't change because they were already in 1 group. So 6 divided by 1 is 6. Now I want to talk specifically about 0 because there are some things that you need to understand about this. It is a rule in mathematics: you can never, ever, ever divide by 0. So this first statement of 6 divided by 0, this in mathematics is called undefined. And that's kind of like a mathematician's worst nightmare. So undefined means it doesn't make sense, doesn't compute, isn't working, it's nonsense. It doesn't work. So, and the reason that it doesn't work is if we go back to the logic that we've been using so far, that division represents the separation of items into equally sized groups. If you took 6 items, if you took 6 apples and tried to divide them into 0 groups, that doesn't make any sense. You're not going to be able to do it. You can take 6 items and divide it into 1 group. That's 6 divided by 1 is equal to 6. but 6 divided into 0 groups, you have to have some group, some number of groups to put the 6 items into. So 6 divided by 0 is always undefined because it doesn't make any sense. It's mathematically impossible to do. However, 0 divided by 6 is 0 because we can take 0 number of items and divide them into equally sized values groups. Equally sized groups. It's just that each of those groups would contain 0 themselves. So if I take 0 apples and divide them among my 6 friends, just each of my 6 friends gets 0 apples, but I can actually divide them into equally sized groups. So, long story short, any number divided by 0 is undefined. 0 divided by any number is always 0. If you have any questions, then please let me know. Otherwise, let's take a look at these few examples that we'll solve together. So if we just think about this visually, if we have 8 units and we're separating them into 2 groups, and they have to be equally sized, so you might put 4 here and then 4 here. So 8 divided by 2 is equal to 4, because if you take 8 items and divide them into 2 equal groups, then each of those equally sized groups would contain 4 items each. So 8 divided by 2 is 4. If we have 6 items and we divide them into 3 equally sized groups, then you would be able to put exactly 2 items in each group. So therefore, 6 divided by 3 is going to be equal to 2. So if we have 10, the third example, if we have 10 items and we split them into 5 equally sized groups, then you'd be able to put 2 in each group. So 10 divided by 5 is equal to 2. If you have any questions, then please let me know. So just like multiplication, there was a separate process. We first started thinking about multiplication in the same way, where we had visualizations, where we visualized these items being projected a certain number of times over themselves, and then counted up all the items in order to sum for a final answer. But we moved past that to a process involving aligning the numbers vertically and by digit orientation, and then going digit by digit, multiplying. When we get to when we carry over to the next value of digits, so from the 1's value to the 10's value, we placed a placeholder, or we put a placeholder 0, and then we continued multiplying, and then we added all the values up. So if that sounds brand new to you, I would recommend looking at last week's streams. But division also has a separate process other than the visualization and memorization of the 1-digit quotients that are helpful to memorize. So knowing that 8 divided by 4 is 2, those are things, and like 9 divided by 3 is 3. Those are things that you're going to become more familiar with as you see them over and over again, and they will become committed to memory. It's just you see them so much. But with more complicated values, there is a process, just like with multiplication, in which we can divide more complex values into each other. So, much like multiplication, when we're dealing with more complicated values, we first want to convert the written version into a more useful format for solving. Write the number being divided under the division sign, and a division sign looks like this. And place the value representing the number of dividing groups to the left of the division sign. Divide the leading digits of the inside number by the outside number and round down to the nearest whole number. place this number on top of the division sign directly above the digit that was originally divided. Multiply the new top number by the outside left number, place the result below the digit you originally divided by, and then subtract the numbers. Carry the next digit down if needed, and then repeat until all the digits have been divided. So that was a lot. It's a lot easier to understand with a few examples. So the first example here is 24 divided by 2. So 24 is the number being divided into, so I'm going to put it underneath of the division sign. 2 is the divisor, that's the number I'm dividing by. So 24 divided by 2, notice that it's a little tricky because the orientation kind of flips around. But we have 2 on the outside of the division sign and 24 underneath of the division sign. We're going to go digit by digit. So starting with the leading coefficient, which is a little bit different than the multiplication process where we went ones times ones, ones times tens, ones times 100. We kind of went from left to right. Here we're going to work we went right to left in the multiplication process, right to left in the multiplication process. Here we're going to work left to right. So starting with the leading coefficient of 2 and the tens value of 24, I'm going to take 2 divided by 2. 2 divided by 2, 2 can go into 2 one time because 2 times 1 is 2. You can always reverse the logic and think about it as a multiplication problem if that makes it easier for you. So because 2 times 1 is 2, 2 divided by 2 is 1. Now I'm going to multiply this new value that I've written above the original digit I divided into. I'm going to multiply that value by the number on the outside. So I'm going to have 1 times 2. 1 times 2 is 2. So I write that underneath of the value here, and we're going to subtract. So the leading coefficient of 2 was divided by that outside value of 2. 2 divided by 2 is 1 because 2 times 1 is 2. So I put that on the top of the division bar, multiply through, 1 times 2 is 2, and now I'm going to subtract. 2 minus 2 is 0. So now I don't have anything left to divide into, so I can carry down this 4. So I carry the 4 down, and now I'm going to divide again. I'm going to ask myself, what is 4 divided by 2? That number that's on the outside. 4 divided by 2 is 2, because 2 times 2 is 4. So 4 divided by 2 is 2, so I'm going to put 2 on the top of the division bar sign above the digit of 4. Now I'm going to multiply that value of 2 by the outside value of 2. 2 times 2 is 4, and when I subtract, I get a remainder of 0. And that's what you would normally expect if you're going to, well, not that you normally expect that, but in the beginning levels of the problems we're going to see, we're not going to deal with decimal numbers. So when we have a remainder of 0, that means that our answer is an integer value, is a whole number. So you'd only have a remainder if your answer actually contained a decimal. So in all the problems we're going to see today and this week, they're going to be whole numbers. They're going to result in integer quotients. Quotients are the answer to a division problem. But that's not, of course, always the case. And we are going to look at some problems later on that involve decimals. If you have any questions, then please let me know. Otherwise, let's look at 363 divided by 3. So I'm going to write 363 underneath of the division sign, and I'm going to put 3 to the left of it. Going digit by digit, 3 divided by 3 is 1, because 1 times 3 is 3. Then I'm going to multiply that new value 1 times the outside value of 3. 1 times 3 is 3. Subtracting away, that gives me 0. So then I need to bring this extra digit of 6 down. 6 divided by 3 is 2. So I'm going to put 2 above 6 and then multiply through. So now I'm going to be multiplying this 2 by the outside 3. 2 times 3 is 6, so I'm going to write that below and subtract. That gives me a remainder of 0, so I can bring down that last 3, and I divide once more. 3 divided by 3 is 1. 1 times 3 is 3. And so when I subtract, I now have a remainder of 0. And so 363 divided by 3 is equal to 121. If you take 363 apples and split them into 3 equal groups, each group would contain 121 apples each. And the last example here, let's look at 482 divided by 12. Now, the outside value has more than one digit. So that's okay. If you can't, so obviously you can't just take one digit, the leading digit, from the inside number. You're going to have to look at the leading 2 values. So now I'm going to look at 48 divided by 12. Because the value on the outside of the division sign is more than one digit. So I need to go beyond one digit in the value underneath of the division sign. 48 is divisible by 12. That's not always going to be the case where the value is exactly divisible by it, and that's okay. We'll see some examples with that. But 48 divided by 12 is 4. Notice I'm not putting the 4 above the hundredths place because I had to take 2 digits into the inside value. So I need to put the 4 above the 8, not above the 4 in the value underneath the division sign. Now, multiplying through, we're going to take 4 times 12. 4 times 12 is 48, so when I subtract, I get a remainder of 0, and I can bring down the 2. Now, 2 is not divisible by 12. So what we have to do, we don't have any value to bring down anymore, so what you can do is you can say that 12 goes into 2 0 number of times, and so you can add a 0, bring down a 0 to add to the value below. Now 2 is divisible. Oh, what happened here? Let me just check something real quick. Oh no, I'm sorry, there's a typo here. I did not want this to be a decimal. I'm so sorry. What happened here? So this has let me just go through this. So this is, so now we would divide 20 by 12. 12 doesn't go a whole number of times into 20, but it does go at least one time into 20. And that's going to be 1 times 12 is 12. Subtracting away is going to give us 8. So now we can't go any further, so we would go into the decimal version, and I do very much apologize. There's a typo there. I think this was supposed to be, there was an extra 2 there, so 48 divided by 12. So this is actually going to have a decimal answer, so let's scrap this, and let's think of actually just this 48 divided by 12. So I was really going for with an outside value with more than one digit. So when you're dividing by a value with more than one digit, like I said before, we have to go beyond the leading coefficient of 4, or the leading digit of 4, and we have to think about the number as 48. 12 goes into 48 4 times. 4 times 12 is 48, and so it's an exact multiple, and there's no remainder. So 48 divided by 12 is equal to 4. So going off that second example, if you have any questions, then please let me know, and I do apologize for that typo. If you have any questions, just type them away. Otherwise, let's look at these two examples. I'm going to give you 3 minutes, and I'd like you to look at 8 divided by 4 and 9 divided by 3. I'll keep track of the time in the upper right-hand corner, and I'll update it every minute. So you can solve these values because these problems are one-digit numbers. You might want to solve them with the visualization technique that we started with, where you represent them as individual items and split them into the number of groups indicated by the second value. Or you can try and orient them vertically and divide that way. I'll give you 3 minutes and then we'll go through these. Okay, so for number 1, 8 divided by 4, if we have 8 units and we split those 8 units into 4 groups, equally sized groups, then you would be able to put 2 units in each group. So 8 divided by 4 would be equal to 2. For number 2, if you have 9 units and you split those 9 units into 3 equally sized groups, then each of those 3 groups would have 3 values in them. So 9 divided by 3 is 3. And that's due to the fact that 3 times 3 is 9. Notice that 9, 4, 16, 25, these are 36, 49, 64. Those numbers are all, what's called perfect squares. And when we get to exponents, talk about exponents, that'll become relevant, but they are a number times itself. So 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, so on and so forth. So this is a perfect square, so 9 divided by 3 is 3, because 3 times 3 is 9. If you have any questions, then please let me know. Otherwise, take a look at these two problems. I'm going to give you 3 minutes, and then I'll give you the solution. Okay, so again, we can think about these visually. If we had 15 items, you could literally draw out 15 dots and split them among 5 groups equally. But we want to get to a point where we think about these or solve these types of questions more conceptually, because that's going to be quicker. If we think about division as being the opposite of multiplication, which it is, ask yourself, with this second number here, what number times 5 is 3? So let me write that out. Excuse me, not 3, I'm sorry, is 15. You got that completely, and I kind of gave that away. That's not just a random number. Notice that 5 times 3 is 15. So that's where I just did that mental slip. So I'm so sorry. What number times 5 is 15? That's 3. 5 times 3 is 15. So 15 divided by 5 is 3. So that's a quicker way to start thinking about these problems. You can invert them and ask yourself what number times the value would give you the other number. So for example, 14 divided by 7, we can think of as conversely, what number times 7 is 14? Try and say it right that time. What number times 7 is 14? That's 2. 7 times 2 is 14. So 14 divided by 7 is 2. If you have any questions, then please let me know. Otherwise, let's take a look at the next two problems. Now with these, now we have a 3-digit number divided by a 1-digit number. You're probably going to want to orient these vertically and then divide as we did, as I showed you in the beginning of the lesson. So you first want to orient, I'll orient the first one for you. So we'd have 448 divided by 8. So we have 448 underneath of the division sign, and we have 8 outside of the division sign. Okay, so I'm going to give you 3 minutes and then we'll review. Okay, looking at the value underneath the radical, or excuse me, not radical, division sign. Radical signs look very similar to division signs, but this is a division sign. Looking at the number underneath the division sign, the leading value, leading digit of 4 is not divisible but in a whole number of times by 8 because 8 is larger than 4. So instead of just considering 4 initially, I'm going to consider the number 44. So how many times can 8 go into the number 44 times, or 44? Go into the number 44. Now, 8 does not go into 44 in even or in a whole number of times, so we're going to have to round down. Notice that 8 times 5 is 40. 8 times 6 is 48. So 44 is in between 40 and 48. So I know that 8 can go at least 5 times into 44. So I'm going to write a 5 underneath, above of the one-digit value of 4. Not above the first 4, but the second 4, because I had to consider 44, not just 4 in the initial division. Now I multiply. 5 times 8 is 40, and I subtract. 44 minus 40 is going to give me 4. 4 is not divisible by 8 itself, so I bring down 8. Now, 48 divided by 8 is going to be 6. 6 times 8 is 48, and so you can see that we have no remainder. So 448 divided by 8 is 56. If you have any questions, then please let me know. Let's look at the second question. 474 divided by 6. So again, that leading digit of 4 is not divisible by 6 a whole number of times. So I'm going to consider 47 instead of just 4. So how many times does 6 go into 47? Well, 6 times 7 is 42, and 6 times 8 is 48. 47 is in between 42 and 48, so I know that 6 can go at least 7 times into 47, because 7 times 6 is 42. Now I subtract, and I'm going to get 5. 47 minus 42 is 5. But 5 isn't itself divisible by 6, so I'm going to need to bring down that 4. And now I'm going to divide 54 by 6. What number times 6 is 54? That's 9. 9 times 6 is 54. Subtracting away, you'll find a remainder of 0. So 474 divided by 6 is equal to 79. If you have any questions on anything that we've done today, then please let me know. And remember that I'm going to be doing a recording for session 2, hopefully either tomorrow or tomorrow night. Or Friday morning, but before Friday's class, I'll hope to have a session 2 recording up, and then we'll meet on Friday at our normally scheduled time for session 3. If you have any questions, then please let me know. I'm available and here for you at all of my social medias, addresses that are linked in the description below. And if you find these videos helpful, then feel free to subscribe and like the stream, and I appreciate you very much. Otherwise, Dr. Todd, are you going to say goodbye to everybody? I think he earned a cookie. Come on, do you want to say goodbye? You guys say goodbye. Say bye. Bye. All right, thank you guys very much for watching. I hope you have a wonderful night, and I'll look out for that recording, and I'll talk to you on Friday.